Okay, so suppose there is an input file, okay, which comes from the client every day. In that input file, you suppose you have multiple data, employee name, employee salary, employee company name, say employee address. This kind of data you have, okay. So in this file, there is a field called employee company name. Now in this input file, there may be thousands of records.
Yes.
Now also the client has given you a list of company names. Suppose IBM, TCS, CTS, Standard Chartered Bank. These four companies the client has given you. That in our input file, whatever records we are sending, if that employee is part of any of these four companies, then only that record is a valid record. Otherwise, it should be ignored. So this file comes and this file is processed in a Cobol DB2 program, and there may be multiple business logics. Okay, you are reading this file and loading the data in a table, or there may be there may be many business logics. Out of those business logics, one basic logic is that the employee that comes in the input file should be out of these four companies. That means his company name should be either IBM or TCS or CTS or Standard Chartered Bank. If it has a different company other than these four, then that is an invalid record. We should not consider that. We have to ignore. This kind of cases we have to handle through arrays. Now there are multiple ways of handling it. Normal one is how we normally read a file. Read first file, okay. Then take a record and then read second file and till the last, till the last record. That means read first file, take any company name and try to scan that company name in the second file. Okay. Again, read the second record of the first input file, take the company name and scan it here. If it is matching, then take the record. If it is not matching, ignore it. You have to set some flags to either take or ignore. Then read the third record of first input file and scan it. Read the fourth record of input file, scan it like that. If in the input file you have 1,000 records, for all the 1,000 records, you have to scan the output file. So this will finally give a performance issue, because this is okay for less number of records. If the input file has 100 records, output file, if the first input file has 100 records, second input file has 4, 5 or 10, 15 records, then it is fine. But if the first input file has 1 lakh records and the valid list of company is also like 500, 1000, then it will give you performance issue, because for each record you are scanning the full output file, full second input file. So this approach will not work here. So in this kind of cases, we use array. What we do is these four company names which the client has given us, we write it into a file, okay, and write the file into an array. This one, because once you write the records into an array, fetching data from array and matching it and processing it takes much lower time and CPU processing time than searching the records in a file and processing them. That is why it is easier to write the files in array and then processing it. So write these four records into a file and then write the file into an array through the program. Then read the main input file and search it from the array. That is the scenario where search all will work. Search all will work faster than search, because in search it will start searching from the first element of array. For example, if the company name is SCB in the main input file, it will still start searching from the first record till the last until it finds it. But search all, what happens is, in case of search all, we arrange the records in array, these records in ascending order of the names, And then search all, what it will do is it will divide the records from in between, and it is kind of a binary search. It will find out very easily, very quickly.
Practice.
Okay, so this is the only scenario where array is used, when you have an input file where it can have any field which has to be validated somewhere. And for that validation, the client probably has given you a list of names or list of IDs or codes or anything. So the client will not tell you that you have to use array for that. He will just give you these names in a mail or in a document. What we have to do is we have to think, and we have to create a program, and we have to create a file for this, and we have to create, we have to scan, we have to read the main input file, and then we have to read from the array to find out the element. That is when search and search all are used. Is the only scenario. And
ओके,
search all
तो
are
यहाँ पे
very
हम
much.
लोग
Hmm?
सर्च और दोनों लगा सकते हैं ना, ये फाइंड करने के लिए?
दोनों यूज कर सकते हो.
ओके।
Or this is very much project specific. If you don't have this kind of a requirement, you will never be able to use search all, because if you don't have a requirement, why will you use? It's project specific. Okay. Second one is subprogram, right? Static call. Now subprogram is also a COBOL program which is called from another COBOL program. Okay. That means from a program, if you call another program for anything, that is called the call program is a subprogram, is called subprogram. The calling program is main program. Now, why is a
यस।
subprogram? Why is a program called from a main program? There are two things. First one, if you are using an input file and you are evaluating one output file, okay, and the evaluation of the output fields are very lengthy. Suppose the output file has 5 fields, out of which 3 are easy, and the evaluation process of 2 output fields are very lengthy. There are a lot of calculations and evaluations for those 2 fields. Okay. Now, if you write the entire logic, suppose the evaluation of one field is only 1,000 lines. If you write the entire logic in one program, sometimes the program becomes very messy and the logic is very difficult to understand sometimes. That is why what we do is that part of code, like the evaluation part of fields, the complex fields, we keep in another program, and we pass the value from the main program for input value, pass the input value from the main program to the subprogram, and the evaluation is done in the subprogram, and the output comes back from subprogram to the main program. Okay. That way, the main program becomes simple, and also the point where it is calling the subprogram, we can go to the subprogram and we can try to understand the logic. So that way it becomes clean. So this is part of COBOL coding standard. Okay, we have to keep the code clean and disciplined so that it is easier to understand. It is not like you know logic, so it will make the program very difficult. That is not COBOL standard. Second thing is, sometimes there are some evaluations which are common in many programs. For example, some date format check is there. There are many programs in your project where initially a date format check is there. Like in input file, on date comes in the format of YYYY hyphen MM hyphen DD. Okay. Now this kind of date comes in many programs. What we do is we validate this date. For example, first of all, we check the first 4 characters. It should be more than 1900, and it should not be greater than current date. Then fifth element and sixth, seven, eighth element should be hyphen, not anything else. Then this month should be between 1 and 12. Okay, and day should be between 0 and 31. And suppose January, March, May, July, August, October, December should be 31. Then February, if it is leap year, should be 29. If it's not non-leap year, it should be 28. Remaining months should be 30 days. All these kind of validations are there with this date format. Now, since this is common, what we do is we write a program for this kind of date check. And in all those main programs where this kind of date check is there, in all those programs, we call the same subprogram, because the subprogram is generic. And from suppose in 10 main programs, we are checking the date format. From all those 10 main programs, we pass the input value from the file, we pass the value and we call the subprogram. So this is another case where subprogram is used. So first one is when we want to make the program very clean and disciplined, that time we use subprogram. We write the complex logics in the subprogram. Second is when we have common calculations or date format check, mostly date format check I have seen, then we use subprograms. Now to call a subprogram, from the main program we call it this way. Call, suppose the name of the subprogram is sub pgm using wsa. This way we call. So this is only called static calling, because I am from the main program I am calling the subprogram with its name. This is the name of the subprogram. I have kept the name within single quotes and I have written using wsa. So this is called static call, when you call something by its name directly. For example, if someone calls you Saurabh, it is static calling, direct calling. Sometimes what we do is we call a subprogram with the help of a variable, suppose wspgm using wsa. Now what is wspgm? It's a variable. Now in this variable, suppose we pass the value from runtime from JCL. So in the program we will write it this way: procedure division, suppose accept wspgm. Accept is when we pass a value from sysinddd star of a JCL, that value should be accepted in procedure division using accept verb. So accept wspgm in the JCL, we have to write it this way in the execution JCL, not the compilation one. Sysinddd star. Here we have to write the program name sub pgm. So when you execute the program from the JCL, this subprogram name will come and it will be accepted in this variable. So the value of wspgm will be sub pgm, and you are calling sub pgm but with a different name, with a variable. This is called dynamic calling. Dynamic calling is in at the runtime you are passing the value. At any time you can call different program with it. If you pass a different name, it will call a different program. So this is called dynamic calling. This is called static. Static is when it is hard coded, the program name. You are calling with the name. Dynamic is with the help of a variable you are calling and the value you are passing from GCL. Understood?
तो बेसिकली प्रोजेक्ट में हम लोग स्टैटिक डायनामिक दोनों यूज करते हैं या फिर कोई
स्टैटिक
एक
ज्यादा
यूज
यूज
करते
होता
हैं?
है। स्टैटिक
अच्छा।
ज्यादा यूज होता है।
ओके।
अंडरस्टूड ना?
यस यस, क्लियर।
So these basic programs I think you already know. Addition. So these are basic programmings, okay? So I have taken four variables, W as A, B, C, D. Value of A is triple one, value of B is triple two, value of C is triple three. I want to evaluate the value of W as D. So I've initialized it because there is no value currently in WSD. So I've initialized it. Then I have written compute WSD equal to W as A plus B plus C. So it will add all those and it will evaluate the value for this. Now always keep spaces before plus sign and after plus sign, because the program, otherwise the system will get confused if you write it this way. It will think it as a variable name sometimes, total one. So always give a space before and after. Okay, easy na?
यस।
Normal plus minus. If you want to subtract, you can write it this way: minus minus, subtraction, hyphen. In this way, though, definitely you have to give spaces, otherwise it will be totally difficult to understand. The system will not, it will throw compilation error because there are so many hyphens. This hyphen is part of the name, this final is the hyphen is part of the operation. This is subtraction mark and this is part of the name. But system will consider it to be a full name, so it will give you errors. If you want to multiply, then in place of hyphen you have to give star. like this. If you want to divide, you have to give slashes. So you have to remember the signs, okay? Slash for division, star for multiplication, hyphen for subtraction, plus sign for addition.
Yes.
So basic if else logic, if you want to study, it's a basic, very easy one. I have taken two variables, WSA, WSB. The value of WSA is 2, value of WSB is 1. I have written if WSA, this is less than sign, okay? This is less than sign, this is greater than sign, this is equal sign, this is not equal sign. For not equal, you have to write less than greater than, okay? Or you can write this one also. This also means not equal, okay?
Yes, but
Now, if WSA less than WSB, display A1, else display A2, and if stop run. So, what is the meaning of this? Can you tell me which
the
display
value
will come?
of WSA is less than display WSA is. It will come A2.
A2, correct?
Yes.
Because this is false condition. WSA is 2,
Yes.
WSB is 1. 2 is less than 1, that is the false condition. It will go to else part, it will display 2, A2. Now, these are the only scenarios where you don't have to write the period. This full stop is called a period. You don't have to write these periods in
If else.
if else, read and read, start and start, then evaluate and evaluate, perform and perform. Within this, these are loops, okay? This period will mean the loop ends. If you write period here by mistake, what will happen is the system will understand that the loop ends here after A1. Then this part will become meaningless and there will be compilation error for this part. That is why we have to write full stop after the last. This is called scope terminator, this is called verb. It's called scope terminator. End if, end start, end read, end evaluate, end perform. These are all scope terminators. And stop run is the last line. You understood this program. Now I don't have to execute it.
Got it.
This example, here we have if inside if. This is called nested if. Nested if means if inside if. I have two variables, WSA and WSB. WSA's value is 1, WSB's value is 2. If WSA is equal to WSB, display A. Else, if WSA is greater than WSB, display B. Else, display C. End if, stop run. So, can you tell me which display will come?
C.
Okay, first it is checking the equal condition. If
This will be false.
WSA is equal to WSB, okay, so it is false, it is not equal, 1 is not equal to 2, it will go to else part. In else, it is checking if it is greater than B, if A is greater than B. It is also false condition, 1 is not greater than 2. In else part, it will go to else part and it will display C. Okay,
Yes.
and here see, and this layout is very important to maintain. So I have written if here at 12th position. This else is not mandatory for if, okay? If you have a scenario, if you have a requirement, then only write else, otherwise not mandatory. But end if is mandatory. After under if, exactly under if I have written else, then exactly under that I have written end if. Okay? Then this if is under this else, and exactly under this I have written else, then I have written end if. And I have written the full stop or period only after the last scope parameter, not before that. Okay? After the last scope
So,
terminator, I have written this.
so in that case, can we write any condition with only if and if? No, we can skip else
Yeah,
part
yeah,
if we don't need
yeah.
that.
Else is not mandatory. Else is only written if you have a business requirement, then only. If you want to check only equal condition, if the client has checked, told you that check if both are equal, then display this. Nothing else. He has not said anything else. Then you have to write if this equal to this, display and if. But if we have said that check if both are equal, if equal, then display this. If not equal, then display that. Then only you have to write if. Okay.
Got it.
This is another. This simply I wrote. So here if you see I have taken a variable ws name, picture clause x of 8 value this one. Now I'm checking if ws name is Hamid, display Hamid. Else if it is Fatima, display Fatima. Else if it is Manoj, display Manoj. Else Gautam, display Gautam. Else Vivash, display Vivash. Else if it is Sheikh, display Sheikh. Else display ws name. So the value.
Having this will know the position. It is
Hmm?
seems complex. Position seems complex for this.
Yeah, position you
How
have to. The position you have to maintain. You have to calculate the position. See this if exactly under this you have to write else. Then go down, then press F8. See exactly under this you have to write end if. Then go to top again. Go to the next if. This else is part of this if. Go down F8. See this end if. Like this you have to maintain. This is one end if. F7. Sorry, arrow up arrow. Then F7. See exactly same. Exactly at the same position. So you have to maintain this, otherwise you'll get confused, which is part of what? You'll not understand the logic only.
hello?
Yeah, hello?
Yes, yes.
Got it now?
Yeah, got it clear.
Okay, so we have a concept called renames. Okay, renames is, see there is a variable I have taken ws hello1. It has two sub-elementary variables wsa, wsb. The value of wsa is IBM. Value of under wsb we have two sub-elementary variables c and d. Value of c is mainframes. Under d we have two sub-elementary variables e and f. Value of E is under F there are two G and H. Value of G is D. Under H there is one WSI. The value of that is best. Now if I display WS hello one, what will be the output? Any idea?
It will display complete IBM mainframe is the best.
Hmm. If you display WSA,
IBM
WSB,
mainframe,
how? Under
but
WSB there are two.
to WSC mainframe is
Under D again there is two. There are two.
okay. So if we display WSB, then it will reflect mainframe is the best.
Yes. And if you display WSC, it will be mainframes. If you display WSD, it will go till the last is the best, because under WSD you have two E and F. Value of F is the best, value of E is the best. Now with this normal kind of displays, what you can do is you can control the beginning part, but you cannot control the end part. For example, if you want to display WSB, you can control that from this position you want to display, but you cannot control that I want to display from here to here. You cannot control this. If you
Hmm.
display any variable, by default it will display till the last position of the variable,
Hmm.
correct? That is
Yes.
normal display. Now, if you have a requirement that I want from B to D, B to E, suppose from here to here you want to have display. How will you display? It is not possible with normal displays. That time we use renames concept. So this is called regrouping of sub-elementary variables. All these are sub-elementary variables. This is group one, and all these are sub-elementary variables. So if you want to display from here to here, or from here to here, or from here to here, from any position to any position in a variable, you have to use renames. So for rename, 66 level number is used. I have taken two variables, 66 WSJ renames A through G I have written. A through G means from A till G. IBM mainframes is the, from here to here it will come.
Okay.
Second display is WSK renames G through I, from here to here. So in normal case, if you display WSG, display will be output will be D. If you display WSH, output will be best. But if you want to display from here to here, you have to use renames the best. Now after that, I have displayed WS hello one normal display. It will display till the end. IBM mainframes is the best. Then I have displayed WSJ, then WSK. So let me first compile and then execute it. WS hello one. So it will display the
IBM.
full thing. IBM mainframes is the best.
Yes.
Then WSJ, WSK. WSJ is A through G. A through G. IBM entrance is the dot. Is the. IBM entrance is the. Third is WSK, G through I. From here to here. The best. The best. So this is the difference. If you do a normal display, you can just control the beginning part. Like from here, I want to display, but you cannot control the last. It will by default display till the last. But if you want to display from display a range of variables from here to here, here to here, here to here, you have to use renames concept. It is very less used though in programs. I have never used actually in my career.
Okay.
Okay, but you should know the concept. If any time you want to use this, you have to use this.
They are renames and redefines, I think, these terms. I'm
Hmm.
not